The second way that we're going to look at solving these equations is by substitution, all right? Substitution. Now with substitution, just like if you play a sport and you sub in volleyball, you usually sub in the same player, right? If you are in basketball and you take your forward out, you're going to have someone that's going to play that forward position, all right? So it has to be equal in order to substitute, okay? Has to be equal in order to substitute. And so what you're looking for with substitution is that at least one of your equations has a variable all by itself, okay? And so for the first one, they gave us an equation with a variable all by itself, and we're just going to use this top one, even though they gave us both of them. Y is all by itself, and they're telling us it equals negative 4x plus 8. And so for substitution, we are going to take this side of the equation and plug it into the other equation for the variable that we say it equals, okay? So if y equals negative 4x plus 8 in that equation, in the next equation, we are going to rewrite it but replace this y. And so instead of writing y, I'm going to write negative 4x plus 8. And I'm going to say it equals the x plus 7, okay? So I have negative 4x plus 8 equals x plus 7. This is an equation that I should be able to solve. How do I solve an equation like this? I'm going to move my 4x over, all right? So I'm going to move my 4x over, solving equations, add my 4x to both sides, all right? On the left-hand side, my 4x cancels, all right? And I'm left with just an 8, just this 8. On the right-hand side, 1x plus 4x equals what? 5x. And I also have my 7. So I have 5x plus 7. So I have all my variables on one side. I am going to move my numbers to the other side. So I'm going to subtract my 7. It cancels on the right. On the left, I have 1 equals 5x. And my final step is to divide by 5. So x is going to equal 1/5. All right, 1/5, or 0.2, depending on which way you do it, right? 1/5 or 0.2, okay? Now, in order to solve this equation, this systems of equations, I must have an xy. Whether in fraction form or in decimal form, I have to have an xy. So if I have my x, I need to solve for my y. How do I do that? I have an x, I need to solve for y. Well, I have two equations I can choose from. I can just plug it in, all right? So let's say I take this second equation here. All right, so let's say I take this second equation and I plug it in there. So I'm saying, what is my y? Y equals 1/5 plus 7, or 7 and 1/5 if you write it as an improper fraction. That's what? 36 over 5, right? If I write it as a decimal, that is going to be 7.2. But this would be my answer. 0.5 and 7.2 are 1/5 and 36/5. Now, if I had graphed this one, it would be really hard on a graph to say, oh, that's 0.2 and 7.2. Definitely that's my answer, right? And so while graphing works very nicely when they cross beautifully on an XY, graphing can be difficult because you have human error involved with graphing, right? If you can walk and do it across hairs, we're great. But if you walk and it's at 0.2 and 7.2, you're going to have a hard time telling me that's the exact value of your XY. And so substitution is more accurate. Substitution is more accurate. It's going to give you the exact value, 0.2 and 7.2. All right? So your first step for these, your very first step is to make sure that you have one variable by itself in one equation. All right? So your second step is to take, once you have one variable by itself, you're just going to plug that into the other equation, okay? And solve. So for this one, they already have a variable completely by itself. They have the y equals 2x by itself. So we're going to take the other equation, the 7x minus y, and we're going to replace that y with the 2x that the y equals. So you'll say 7x minus, and we're going to replace that y with 2x equals 15. And then we're just going to solve that. 7x minus 2x is 5x equal to 15, so x equals 3. Now we only have an x value, we need a y. So we're going to take our original equation, y equals 2x, and we are going to replace that x with the 3 that we just solved for. So y equals 2 times 3, or y equals 6. So our final answer here is 3, 6. So then what happens if none of my equations have the variable completely by itself? We are going to take one of the equations and we are going to add or subtract, multiply or divide to get one variable by itself. It does not matter which variable and it does not matter which equation. So what you always want to do is you want to look at the two equations and choose the path of least resistance, right? So I'm going to look at these two equations, and when I look at them, I am going to see a 3 times y, a 2 times x, a negative 6 times x, and a y. Which of those 4 is the easiest to get by itself? In which equation? The y. So which y in which equation? This one. It already doesn't have a coefficient. All right, so this is the equation I'm going to choose to get by itself, okay? So I am going to take this second equation here, and I'm going to say negative 6x plus y equals negative 7. If I want to get that y by itself, I will just move the x over. So negative 6x and positive 6x cancel. I have my y completely by itself. It equals positive 6x minus 7. All right, and I have gotten my y by itself. Think of what you did to do solve for slope-intercept, okay? You get the y by itself. Move everything over, divide by what's in front of the y. It's just easier if you don't have something in front of the y. If an x had been all by itself, I would have used an x. It's okay, you can use either. Now what I'm going to do is I'm going to take the other equation that I have not touched, and I am now going to use that one. 3y plus 2x equals 4. And I am going to take this 6x minus 7 and replace it for my y, okay? Because I said that's what y equals, all right? And so I'm going to write that equation 3, and instead of y, I am going to write 6x minus 7. 3y plus the 2x equals the 4. And I still have something that's rather easy to solve, all right? My steps here to distribute the 3. 3 times 6x is 18x. 3 times negative 7, negative 21, plus 2x equals 4. All right? Combine my like terms. That would be, right, my 18 and 2. 20x minus 21 equals 4. All right? And I'm going to add my 21 over. 20x equals 25. And my final step is to divide by 20. So x equals 25 over 20. All right? We want to reduce it. What goes into 25 and 20?
5.
So we have 5 over 4. Two things you can do. You can leave it as 5 over 4, or you can write it as a decimal, 1.2. Depends on whether you like fractions or decimals. What you do have to do is you have to go back and solve for y. You have to go back and solve for y. That's 1.25, sorry. 1.25. So either way, you're going to have to plug it back in. All right? I usually do it by fractions because that's my preference. All right? Plug it back in. We have x. We need to solve for y. And so when we have x and we need to solve for y, we're going to go back to the equation that it was equal to. Y equals 6 times x minus 7. All right? You have to do fractions or decimals, one or the other. 15 halves minus 14 halves equals 1/2. And so my y value is going to be 1/2 or 0.5. And so that would be my xy value, all right? Find the variable that is easiest to get by itself. Let's look at this one that y'all are going to do by yourselves, all right? 6y, that's not going to be easy, all right? It's going to create fractions right up front. 8x, not going to be easy. 2x, still going to create a fraction. -1y, all right? I can get that by itself. I can move my y over and my 3 over, or I can move my 2x over and divide by -1. So go ahead and try this one. Here. So the equation that you want to get by itself is likely the second equation. If you move the 2x over, -2x plus 3y equals -y. You still don't have y by itself. Everything has to be divided by a negative. So you get +2x minus 3 equals y. You're going to take that and plug it into your other equation. 6 times y plus 8x equals 28. So 6 times my 2x minus 3 plus my 8x equals 28. Distribute. 12x minus 18 plus 8x. 12 and 8 combine to get 20x minus 18. Add your 18, 20x equals 46. Divide by 20, reduce 23 over 10 or 2.3, depending if you like decimals or fractions. Plug it back in. 2 times x minus 3 equals y. That's what we said way over here. So that's 23 over 5 minus 3 or 15/5 is 8/5. 23/10 or 2.3, 8/5 or 1.6 would be your answer for the substitution. Questions on that?